Okay, we're going to keep moving on with our work on finding volume of three-dimensional figures. Today, our learning target is we will develop and use a formula for calculating the volume of rectangular prisms and cubes. So real quick, I want to review a couple things from yesterday that will help us work on creating that formula and using that formula to find the volume of three-dimensional solids. So yesterday we worked on a little bit of vocabulary. We came up with our definition for volume. And volume in math, or especially when we're talking about solids, is the amount of space an object takes up. And what we worked on yesterday is counting the number of unit cubes that were in a solid, because that tells us how much space that object takes up. So we're going to do that real quick. Practice what we did yesterday for this solid. Now, one thing that you should remember from yesterday and that we kind of focused on is sometimes, even when you're using that strategy of counting all the unit cubes, you still need to kind of make some assumptions using what you know about solids. And that's going to happen in this figure. So I would like to start by counting all of the solids in this green top layer. And I'm going to use my yellow marker for you to see that. So I see right here, I'm going to mark these two at a time because I see they're in rows of two. 2, 4, 6, 8. Now I know that in that green layer in the top layer, so far we have 8 solids, or 8 unit cubes. Okay, now underneath there, I see that there is a row of blue and also a row or a layer of blue and red unit cubes. If I know that this top layer, this green layer of our figure, is made of 8 unit cubes, and I see that it is stacked above 2 other layers, then I can also assume that this whole blue layer is also made from 8 unit cubes. And the same thing about this red layer, even though we cannot see all of the unit cubes. Okay, so far we have just figured out this part of our solid. We haven't done anything with this part here. So let's go ahead and work on that. Okay, so I'm going to count by 2 again. 2, starting with the blue unit cubes, 4, 6. And then I also see that underneath those 6 is a layer of red unit cubes, 6 blue. That means that underneath them, for them to form that top layer, there has to be 6 underneath. So what we're going to do to find our volume, we counted those up. I know that was a little bit fast, but we actually counted all of our unit cubes here and here. So what we need to do real quick is to combine those. So think about a strategy that works well for you. If you are a fifth grader who really needs to use a calculator to do this, then that is okay. This unit is not about your multiplication or addition skills. I would prefer if you tried to use your own strategy first and then maybe just used a calculator to check your work. I am going to do 8 times 3 to find the volume of this part of our solid. And I know that 8 times 3 is 24. And then I am going to combine that with our 2 layers, our red and blue layer over here, which was 6 times 2, or 2 layers of 6 unit cubes. And that is 12, giving us a total of 36 cubic units, or 36 units cubed. And that is the volume of our figure. Okay, so after that review from yesterday, we're really going to dig into our learning target from today, or for today, which is developing and using a formula for calculating the volume of rectangular prisms and cubes. So we know that we can count the number of unit cubes in a solid to find the volume, but my question to you is, will this strategy or method always be the most efficient? So first I'd like to ask you, go ahead and look at that solid that I've drawn my blue arrow to. Would it be efficient for you to count all of the unit cubes that make up this figure? I want you to think about how much time that might take you. And even if I try and count this top layer, I'm going to try and do that real quick. by putting blue marks on each one of the cubes. Think about how much that would take us to do times 1, 2, 3, 4, 5 layers. So 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Whew, that took me a while. Now I would have to do that for each one of our layers of our cube to find our volume. So no, when we have a solid that large, counting each one of the unit cubes to find the volume is not always going to be the most efficient way. Okay, now the second reason today that we're going to work on finding a formula for volume, I'm going to draw a red arrow to this next solid. Hopefully what you're noticing is that, oh, whoa, wait a minute. This solid does not have any unit cubes. So how could we possibly use our strategy of counting the number of unit cubes to find volume if there are no unit cubes in this solid? And that is what we're going to work on today, is creating a formula to use, just like we had a formula for finding the area of rectangles, squares, and triangles. We're going to find a formula that we can consistently use for finding the volume of rectangular prisms and cubes. Moving on, here is where we're going to really start to work on creating our formula to calculate the volume of rectangular prisms and cubes. So right here on your screen, you see two separate solids. These solids are both rectangular prisms. We're going to start by talking about solid A. Since none of the side lengths are labeled, we're going to go ahead and work on doing that together. When we look at a solid, we are going to be measuring or counting and labeling the length, the width, and then how high the height, or how many layers high the solid is. And sometimes that will be labeled for us, but when we're just starting today, we're going to do it ourselves. I'm going to start with my length right here. So I'm going to write L equals, L stands for length. And what we're going to do is just count how many unit solids make up this part of our rectangular prism, or this side. So 1, 2, 3, 4, 5. 5 unit cubes. Next, we're going to measure how wide, right here, our solid is. 1, 2, 3, 4. W, oops. We're going to use W as our width measure, or how wide our solid is. And so I counted there are 4 unit cubes here that make up our width. And then the height is how many layers, or how high our solid is. And I can see it is only 1 cube high. Okay. Now, after I found that, and I'm going to erase those lines real quick, or try. It's taking me a little bit. There we go. Okay, now what we're going to do for this first figure is we're just going to think about what we know about multiplication. This kind of shows us an array, actually. If we know that this row here is 5, what we can do is count how many rows of 5 there are. So you see that there's 1, 2, 3, 4 rows of 5. So what we're really doing is multiplying our length times our width, 4 times 5. And I know that our volume is going to equal 20 cubic units. Okay, now that is in the case of a solid that does not have a second layer. So all I did was find how many unit cubes made up one side, or my length, and then I multiplied that by how many rows of 5 we had. So you could count that here too. I count 1, 2, 3, 4. So 4 times 5 is 20. Okay, now this solid over here is a little bit more complicated. So we're going to do that same thing where we are going to measure our dimensions, or our length, width, and our height. And I'll talk a little bit more about these as we get into some other solids, but let's start with our length. I'm going to count this side right here in green as my length, and I'm going to count up how many unit cubes make that up. 1, 2, 3, 4, 5. Okay, so I'm going to put that by my L, which is length. Now I'm going to do the same with my width over here, which is how wide my solid is. 1, 2, 3, 4. And I put that by my W for width. And then one thing I noticed about this solid that's a little bit different is how tall it is, or how many layers there are. And I can count that by 1, 2. So this solid has a height of 2. Okay. Now our volume formula, and we're going to write this as V equals, and every time we do this, we're going to write the formula. So to find or calculate how many unit cubes are in this solid, what we are going to do is multiply our length times our width times our height. And we'll talk about this a little bit further on in our unit of how you decide what side is the length, the width, and the height. But think about what you know about multiplication. Should it matter if we were to switch these up? Would our answer be different? If we're multiplying 5 times 2 times 4, or 4 times 2 times 5, or 5 times 2 times 4, if we switch all those up, we're still going to get the same answer. So even if you called this here your height, even if you switch that up and called that your width, it would still be okay. You'll still get the same answer for volume. So now I'm going to rewrite this, and I'm going to, again, plug those numbers in. Volume equals, so this right here is our formula that we're going to use, that we kind of came up with. I'm just going to plug in my numbers, so I know my volume is going to be length times width times height. My length is 5 cubic units. My width is 4 cubic units. And my height is 2 cubic units. Now you can choose how you want to multiply this together. I would recommend finding a combination that's easy for you to do. But we're going to do this kind of one step at a time, step by step. So I am going to choose to do right here 5 times 4 first. I know that 5 times 4 is 20. Cross that off. And then I'm going to multiply 20 times 2. Now you can also look at this as we just found 5 times 4 is 20. That is what one layer of this solid is. And we see we have 2 layers. So we're going to multiply that 20 times 2. And I know 20 times 2 is 40. So our volume of this pink solid, solid B, is equal to 40 cubic units. And we got that by using our volume formula, labeling our length, our width, and our height, and then multiplying all of those numbers times each other. Okay, here's a little bit more practice with our learning target. Again, we're going to work to use that formula of volume equals length times width times height to calculate the volume of rectangular prisms and cubes. So we're going to start with this rectangular prism that is on the left side of the screen, the blue one. I see that the side lengths are not labeled, or our dimensions are not labeled. So we need to do that first, and we can do that by counting how many unit cubes make up our length, our width, and our height. I'm also going to write on here our length, width, and height. We're just going to count those quick to do that. I'm going to do this side as my length. 1, 2, 3, 4, 5, 6. I found that length by counting the sides of the bottom of this rectangular prism, which is the length. And then right here, I'm going to use as my width. And I see 1, 2. And then lastly, my height, which is how tall this rectangular prism is, or you can think of this as how many layers. 1, 2, 3 unit cubes. Okay, now we're going to use our volume formula. And every time you do one of these, I want you to practice writing out that formula of volume equals length times width times height. And then rewriting that, plugging in your values. Volume equals 6 times 2 times 3. Keep in mind, order does not matter. I'm going to start here. I'm going to multiply 2 times 3, which is my width times my height. 2 times 3 is 6. And I'm going to bring down everything else I haven't done. 6 times 6 is going to give me how many unit cubes, or the volume, that are in this figure. 6 times 6 is 36. So our volume for this blue rectangular prism is 36 cubic units. Okay, next we're going to start over here with this second rectangular prism. Now, one of the nice things that is done here is it looks like our length, width, and height are already labeled for us, but one new thing we have to think about is that there are units, inches, on each one of these dimensions, which means we're going to have to do something a little bit different when we write our volume answer. We're going to have cubic inches. We just need to figure out how many cubic inches. So if you can think of this solid here being made up of little 1 by 1 cubic units, that's what we're going to do, is figure that out. Okay? Okay, I'm still going to write my L for length, W for width, H for height. Now when we go to pull those values out here, I'm still going to use this front face of my rectangular prism as my length. So I'm just going to write 5 inches here. Oop, that end didn't work out so well, inches. And then I am going to use 3 right here as my width. And my height, how tall this prism is 4 inches. Okay, now same thing I want you to do when you do your practice, even typing this in. I'd like you to start with our volume formula. We know volume is equal to length times width times height. And then I'm going to go ahead and rewrite that, plugging my values in. So my length is 5 inches times 3 inches times 4 inches. Okay, and you can choose to multiply this step by step however you think would be the easiest. I see right here that 3 times 4 makes 12 times 5. Ooh, and I know this multiple of 12 for me is pretty easy. 5 times 12 is 60. So our volume equals 60 cubic inches. And again, the only thing that's really different about this one is we have actual measurement units on our dimensions. So we need to make sure to include that inches here. And if it were feet, we would write cubic feet. If we had yards, we'd write cubic yards. Okay, this time we're actually going to start with our problem on the right. Again, we're going to be using that volume formula to calculate the volume of this rectangular prism. And the cool thing about that formula, just like our formula for area of triangles, is that this formula applies to every rectangular prism and every cube. We can keep using the same formula. And we'll get to cubes a little bit later in the week. Now, I am going to, right here again, write my length, width, and height measures. And it looks like these are labeled in yards or dimensions. So underneath here, I'm going to write, and I'm going to use my exponent 3 for cubic. And then we're trying to find out how many unit cubes that are each 1 yard make up this solid. Okay. I see that my length, and I'm again going to use this front face, is 10 yards. My width is 6 yards. And my height, or how tall the solid is 2 yards. Okay. We're going to use our volume formula. Volume equals length times width times height. When you get to your practice later, this should be happening every time that you are solving a volume problem. And also this next step of writing V equals volume equals and then plugging in your values should be happening too. So even typing them in, 10 times 6 times 2. Okay. And then you can choose, solving this step by step, what you want to do first. I am going to do 2 times 6 is 12 times 10 equals 120 cubic yards. Okay, now this word problem over here is kind of a challenge problem. I know that when you're first starting out doing this, it's a little bit tricky to visualize these, so it might be a good idea when you do your practice today for you to either draw with your Google drawing tools or kind of visualize a rectangular prism. Now, I'm not going to do that on this one because we'll get some more practice with word problems later in the week, but this problem is a little bit different. I'm going to write my length, width, and height here. And then we're going to pull those things out of our word problem. So I'm going to read this out loud. A rectangular prism has a base, base with an area of 12 square centimeters, and the height of the prism is 4 centimeters. So I'm going to pull that information out. So I'm going to write here 4 is going to be my height, 4 centimeters. And in our answer, I know that we are going to have cubic centimeters. You could write out centimeters. I'm going to write cm to abbreviate that. Now, I do not see when I read all that information, I do not see where it says our length and our width. But what we know, if we have the area of our base or our bottom of our figure, what has already happened is that these two measures, our length and our width, have already been multiplied together. So what we're looking for is a number for our length and a number for our width that, if multiplied together, equal 12. Okay? I know that we could use a whole bunch of different dimensions. We might pick 1 and 12 or 2 and 6. I am going to choose 3 and 4 because I know that 3 times 4 equals 12. Okay, next, we're going to go ahead and find our volume. So what we're going to do, at least for where we're at today with our understanding of volume, we are going to use our volume formula. Volume equals length times width times height to find the volume of our rectangular prism. 3 times 4 times 4. And I'm going to do 3 times 4. I already know that is 12 times 4. I'm going to work down here as I ran out of room. 12 times 4 is 48. So that means that my rectangular prism is 48 cubic centimeters. That is the volume of my rectangular prism.